Hi guys, yeah, glad to be here again after yesterday. So today the topic is a bit different. We're going to talk about next generation cyber warfare, hacking into SCADA systems, vessels, and oil rigs. We're also going to look at some vulnerabilities that conventional and non-conventional electric grids have. Once again, a little bit about myself. If you attended yesterday's session, you would know. My name is Shahmeed Ahmed. I'm the third rank bug hunter, and I've done a lot of research for more than 500 companies. I've written a few books, and I'm a doctorate in applied blockchain security. So today's agenda: evolution of SCADA, hacking conventional SCADA systems, hacking into marine vessel SCADAs, hacking into oil rigs, looking at some widely known vulnerabilities in nuclear power plants, and then we may look at hacking satellite SCADAs as well, depending on time. Okay, so this is what SCADA initially used to be. We had SCADA systems controlling our factories. We had SCADA systems controlling the communication systems and water plants, and helping us in our day-to-day activities. But today, SCADA systems have basically evolved. They have somewhat changed. Right now, SCADA systems are not limited to only controlling factories and plants. They're also expanded into allowing us to remotely control nuclear power plants, satellites, marine vessels, and even defense systems. But let's first look at how this all began. Basically, one of the largest power outages in the history of the world, where approximately somewhere around 50 million people were left without electricity for 2 days, and 3 million people were affected in New York. This was the Detroit blackout. This was not because of a push of a lever or a problem or basically a hack. It was not that. It was because of a software bug. This was basically when softwares were starting to control SCADA systems, and the effects were catastrophic. And after that, you can see that there have been a number of different SCADA systems attacks and malware attacks throughout the years, and after that we are clearly able to see that there has been a rise of SCADA system attacks and malwares, from Stuxnet till the Indestroyer 2 that is currently involved in terrorizing nuclear electric grids and nuclear plants in Ukraine. Let's look at how it all began first.
In June last year, a computer virus called Stuxnet was discovered lurking in the databanks of power plants, traffic control systems, and factories around the world. 20 times more complex than any previous virus code, it had an array of capabilities. Among them, the ability to turn up the pressure inside nuclear reactors or switch off oil pipelines, and Stuxnet could tell the system operators everything was normal. Unlike most viruses, Stuxnet doesn't carry the usual forged security clearance that helps viruses burrow into systems. It actually had a real clearance, stolen from one of the most reputable computer technology companies in the world. It exploited security gaps that system creators are unaware of. These holes are known as 0 days, and the most successful viruses exploit them. The details of a 0 day can be sold on the black market for $100,000. Stuxnet took advantage of 20 0 days. But once it got into a system, it didn't always activate. Buried deep in the Stuxnet code was a specific target. Without that target, the virus remained dormant. What was it looking to shut down? The centrifuges that spin nuclear material at Iran's enrichment facilities. Stuxnet was a weapon, the first to be made entirely out of code.
Okay, without spending more time on that video, we can all agree that all of this havoc relating to SCADA systems, all of it actually started because of Stuxnet. Now, I have a mental exercise for you all. What you see in front of you, I know it's a little blur, but what you see in front of you right now are basically, we can call them weapons of mass destruction, right? These are the B-2 stealth bomber, the Virginia football, the submarine that carries the nuclear weapons all around the world for the U.S., and then the Gerald aircraft carrier. These are all weapons of mass destruction. Consequently, Stuxnet was also a weapon of mass destruction. The cheapest weapon of mass destruction that is of a physical defense nature is costing around $1.01 billion. Stuxnet only costed $100 million in terms of R&D to create. SCADA system basically uses these protocols. The most commonly known is the Modbus protocol, which SCADA systems actually use to communicate with each other. Here, we have a small video which I'm going to show you as to how SCADA systems actually, can be found. We have something called Shodan. Shodan is an online search engine where you can go and put a port in and a relative country related to that port, and it will give you all of the IP addresses where that port is particularly open. It's part of OSINT actually, but at the same time, this website is publicly available information. You can just put in a specific port, just like I said previously. The Modbus port is 502, and you can put in the country as in France, and you will be able to find all of the SCADA systems running Modbus with that particular port open. So yeah. Now let's look at a live hacking demonstration where we will be looking at, a simple mechanism. Siemens PLCs are vulnerable to something called the S7 attack, and the S7 attack was the same attack that Stuxnet was one of the attack vectors that Stuxnet used. And here you can see that what we can do is we can easily exploit that vulnerability using a local file inclusion flaw, and we can create a lot of disinformation-based attacks. Just like we can feed the PLC relatively wrong information to overheat or underheat it. And imagine if this was a nuclear power plant, a temperature difference of even a 0.01 degrees Celsius would cause it to malfunction. What we can do is we can, in the communication tabs, we can go ahead and look at how the PLC communicates with the backend infrastructure. We can review its statistics. We can review the connection resources. And we can also upload and download different coil input and output voltages pertaining to this particular PLC. Here we can check the data logs. The data logs basically contain all of the relevant information that PLC has had. And you can see that there is the active energy, the reactive energy, the potential difference, the average speed, everything. Now, if we edit this file and re-upload it, the PLC will eventually start to malfunction. We can go as far as to turn this PLC off remotely, which would mean that the entire system would shut down. But since we're doing this for demo purposes, we're not going to do that. Anyways, okay. Now let's talk a little bit about this. A few years ago, maybe 1.5 decades ago, a movie called Speed 2 Cruise Control came out. This movie taught us something that we still have not yet learned. That was that ships and boats carry around 83% of our entire transportation all around the world. If the seafarers and the sea lines would stop, the more than half of global trade would entirely stop. But the question arises in people's minds, because ships are also SCADA systems, right? Why would ships get hacked? Well, the reason is very simple. Because you asked for it. People asked for internet in ships, and they installed VSAT. Then ships asked, seafarers asked, they don't want to be crashed with each other. Then they installed the AIS system. And then they wanted to know their own location, so they installed the GPS system. Similarly, the GNSS was installed because they didn't want to recreate the Titanic scenario. And they had comms, so they wanted to speak to everyone. Every single one of this system is in that particular ship, in one way or another, contributes to open source intelligence data, such as this one. Tracking a ship, any ship in the world, is so easy that you have no idea. This is one of the websites called marinetraffic.com, and it basically gathers the AIS data from all of the boats, whether they are parked somewhere or whether they are in the transit of a journey. This basically culminates all of that data and combines it. From here, you can basically see the source, the destination, the heading, the past track record, everything about that particular boat. And once this information is available for everyone to see and everyone to view, it is easily spoofable as well. So let's take a ship here, for example, and see its details. We have this BHAHD, and it was parked in 2019. It's in a dockyard somewhere. And then we have another one. ZAMIL 57. This is a multi-purpose offshore vessel. And similar information can be found from other websites as well. This is, for example, Vessel Finder. This gives a bit more, comprehensive information that you can use. Even if the ship is not contributing to the AIS system, you can still track it. People have weird hobbies, so there's something called ship spotting, where people go ahead and take pictures of ships and boats that are parked in dockyards, and then they upload it. Basically, ship spotting is more of a trend than a hobby these days, because people do it a lot. This was a similar case. One of the offensive vessels from the U.S. Navy was actually ship spotted somewhere in the coast of Panama that actually prevented a war between U.S. and another country. I can't remember that country's name, because that particular ship's location was being spoofed in those countries' water borders. So ship spotting is actually a thing. It's a hobby. Anyways, let's move ahead. Since we spoke about ship spotting, let's look at what ship spotting actually is. Let's look at the same ship that we initially... Remember, ship is also a SCADA system. So we looked at ZAMIL 52, 55. Let's look at from a ship spotting website where this particular boat actually was initially. Or we can track Elon Musk's boat here as well. It's called the Zeus, and you can find out where it has been parked. Currently, it's parked in Croatia for some reason. Anyways, moving on. Now, you can actually use Google Earth to identify ships and vessels as well. And these are sensitive military aircraft carriers. Basically, Google Earth combines the data from 1985 till today. And these are a couple of aircraft carriers that you see that are parked somewhere over the coast of Knoxville. And if you check the date, if you move the timer, you can actually see when this aircraft carrier arrived at this location and when did it leave. And on top of that, you can actually see what jets are parked on that particular aircraft carrier as well. And this is semi-public information. This is not like me hacking into something or doing a live demo. This is semi-public information. So you can use basically all open source intelligence tools to hack into different kinds of systems that you should not be hacking into. And then we will go ahead, since we know the boat's name, we can go ahead and verify that from the vessel finder or marinetraffic.com and see if it's being appeared there as well. And yes, it's called the USS GOVVSSVL. So now you know the name of that aircraft carrier, on top of its location, its trajectory, and if you have a paid account which is worth $5, you can get even more information. So imagine the cost of potentially starting a war today is $5 worth of an account of this website. A hacker, this was what I was talking about. A hacker basically spoofed a ship's AIS system using a transponders to make it look like it was near the Russian border, but in reality it was in port. And it happened because that particular ship's information, the AIS information, was actually being leaked. Here's another very interesting video where you can tamper with the ship's GPS.
Off the southern coast of Italy in June 2013, a 65-meter super yacht and her crew were part of an unprecedented experiment led by the University of Texas at Austin that successfully coerced the vessel off course using a custom-made GPS spoofing device. 30 miles from land, the crew's sense of the ship's location is based entirely on civil GPS signals broadcast from orbiting satellites. A UT student serving as the attacker commands the spoofing device to transmit faint counterfeit signals towards the ship's antennas. The attacker increases the power of the spoofing signals until they are stronger than the satellite signals, gaining control of the ship's navigation system. The takeover is stealthy. No alarms are triggered. Once in control, the attacker initiates a 3-degree change to the ship's course. The ship's navigation system reports that the vessel is drifting slowly to the left. The false location is represented here by the ghost ship. The crew applies a course correction to bring the ghost ship back onto the intended path. In reality, the ship is now on the attacker's course.
So this is how you tamper with the ship's GPS. And it's fairly easy to do it. Trust me, you just need a ham radio. You need to identify the frequencies that the ship is actually tapping into, and you'll be able to do that. Similarly, Shodan can also be used to hack into a ship's internet VSAT system. Sailor 900 is basically a VSAT system that is commonly used in vessels and boats. And if you go ahead and you type in Sailor 900 in Shodan, you will get a list of different VSATs that are high powered and low powered, and you will be able to fairly easily identify which ships are those. So here's something that we did. It was a little notorious, and we had to basically we took the data from marinetraffic.com, and we also took the data from Shodan, and we correlated that data, and then we were able to, in real time, identify vulnerable ships that had a vulnerable VSAT system. We had to intentionally delay the feed by 1 minute so that people should not hack into these systems in real time. So yeah, this is something that we did. Okay, now let's look at a bit deeper, because we've looked at conventional SCADA systems, we looked at ships and boats. Now let's look at oil rigs. Oil rigs are basically the backbone of the world's economy. Believe it or not, there's more oil in the sea than there is on land. We once hacked an oil rig. It was a very conventional oil rig system, and it was very segregated in terms of its networking. But there was one problem. The ship's the oil rig's network administrator, he had to climb every day, approximately 30 flights of stairs every day, 10 times a day, which he didn't like. So what he did was he connected an Ethernet cable to a wire and connected it into the main corporate domain controller network to directly access that system. And which means that particular system was now directly, the system that was controlling the oil rig and all of the critical operations was now directly accessible. And on top of that, the guy had installed TeamViewer to basically gain remote access to that system. So the DCN, which is basically the main controller system of the ship's of the oil rig's internal operations, is now connected to the internet, and that is how we were able to exploit this. Similarly, and this is going to be probably the last case study that we did, the Colonial Pipeline was hacked in 2021. This is the Colonial Pipeline that you see in front of you. It goes all the way from Canada to the US, covering most parts of North America. The pipeline was initially hacked on May 8th. On May 7th, the ransomware attack, it begun. Emergency was declared. On May 12th, allegedly, the pipeline was restored, but in reality, there are other theories about it. There was a national emergency declared about this hack. Now, here is the problem. The pipeline was hacked because of a leaked VPN password that was found on the dark web by attackers. If you were to go on the surface web, or if you were to go on the dark web, bear with me for a second here, tfelt.coalpipe.com. This is the person that is responsible for the system and network administration of the Colonial Pipeline. You can look him up. And the password is coalpipe.com. So 57%, and this is not uncommon. If you go ahead, we will look at, this is a common password across most of the employees of the Colonial Pipeline domain. You will find it encrypted, unencrypted, in one or more scenarios. And these guys actually paid millions of dollars of ransom, I think tens of millions of dollars worth of ransom for this particular hack. There are obviously other layers involved in this particular attack vector, but if you work for a pipeline, if you work for an oil company or a refining company, please don't take threat intelligence for granted. Please recursively test your, change your passwords or, stuff like that. Okay, this is another interesting thing. Now, I have a short video demo where we have listened to live maritime communication, and I'm going to tell you how it worked. Basically, you need a $30 ham radio. You need a whip antenna that is capable of listening to frequencies between 11.3 to 130 kilohertz. We did the demo in KSA, by the way, where it was allowed. We didn't do it here. And we just went on top of the roof, and this is what we found.
Tulsa 9-1, I got you loud and clear. Verify you're at 18-8 now, and you have Romeo at Hill. Tulsa 9-1, Roger. Stay approach request to the Hill Air Force Base.
This was basically a boat that was an aircraft carrier, which was scheduling or green lighting a plane to land on it. And this is live communication that we it was obviously on an open frequency, but it was so easy to intercept that we literally had to buy $40 worth of equipment for it. So the bottom line is, guys, that SCADA cybersecurity is very scary, and the more you take it for granted, the more in trouble you actually get. What I just showed you is only 5% or maybe 10% of the actual threats that are out there. We did this on an open network, on open source intelligence bases, and nothing too notorious. But this information can be very harmful if not taken care of directly. Yeah, I hope you enjoyed today's session, guys. Thank you.
I'm sure of it. Thank you. Thank you very much, Amir. We are going to jump to the questions and answer session. Someone have a question, just raise your hand and we will give you a microphone. Yeah. My colleague will bring you one.
Yes.
Yes. Thank you for your great presentation.
Thank you.
I had a question about the ship detection tool by Ollie Ballinger from Bellingcat. How often do you correlate your information with that type of tool as well, with the those type of satellite interaction tools? How useful do you think they are? Because often I feel like there's a lot of false hits on those. Like, how trustworthy do you feel those tools to be?
Yeah. So all of the AIS systems, whether they are, we know that for the automatic identification system is for ships, is what automatic dependence and surveillance system is for planes. All of these systems basically work on correlated data. Wherever a ship is passing through from, if there are ships or boats nearby, the AIS will actually detect that, share the information with each other, and with every hop, it will try to find a cellular connection or a satellite internet connection to relay that information to the public. What I think the fundamental flaw with these systems is that this is open information, and it should not be like that. The specific system that you talked about is very, very enhanced and providing us a better and baseline security measure for the problems that current ship AIS have. And I think it's going to solve a lot of problems. But the only issue is that how the hell are we going to change it for millions of boats all around the world, because it is 20% of a hardware change and 80% of a software change. So the system is great, but we as humans have a habit of going towards comfort than security. Otherwise, we would not have ended up here.
We're good. Thank you. Congratulations again.